Okay, let's have a little look at the prep tests with full work solutions. So first question, simplify the following expression completely. First things first, with collecting our terms, we need to expand our brackets. We've got to be super careful though, because we have a negative value in front of these set of brackets, not just two. We're taking away two lots of our brackets. So taking away two lots of 4a is equivalent to taking away 8a. Taking away two lots of negative 6b is equivalent to adding 12 lots of b. With the rest of the terms then, minus 4a minus 7b, take away 8a plus 12b, 14a take away 14a take away 8a gives us 6a, minus 7b adds another 12b gives us a positive 5b. So our final solution to A. For B, 4pq times 10qp. Really what's going on here, 4pq is equivalent to 4 lots of p lots of q, and then we're timesing that by 10 lots of q lots of p. So just one long multiplication. If all we have is multiplication, then the order in which we multiply is completely up to us. So we pick out the 4 and the 10 to give us a 40. P times the p gives a p squared, and the q times the q to give us a q squared. Final answer, 40p squared q squared. With C, we're collecting terms. However, being mindful of BIDMAS, we have to make sure we collect this multiplication before we do any adding and subtracting. So we've got two lots of 4d. So let's convert that into an 8d, which is being subtracted. So 2d squared plus 6d minus 8d. So we can't collect the d squares with the d's. So 6d take away 8d gives us a negative 2d. And we still have a positive 2d squared at the start. Alternatively, we could potentially factorize this as 2d lots of d minus 1. But all we're doing is simplifying, and a factorized form isn't seen as a simplified expression. So either of these are fine, but really this is an extra step. So I would recommend just sticking with the first expression. Okay, with D, we're multiplying through three fractions. When we're multiplying fractions, everything gets multiplied on the top, everything gets multiplied on the bottom. And there's a few different methods that we can use here. What might be the simplest approach rather than the most efficient approach would be to bring the fractions together first and then simplify afterwards. So on the top, we've got 3 lots of a to the 4 times 2 lots of b times 14 lots of c squared. Once again, everything has just been multiplied, so we can choose what we bring together with the multiplication. So let's bring the numbers together. So 3 lots of 2 lots of 14. 3 lots of 2 gives us 6. 6 lots of 14 would give us 84. Bringing the letters together, we've got 3 different letters. So let's just have them in in alphabetical order. So a to the 4 b times c squared. In the denominator, once again, we're just multiplying everything together. We can choose what we bring together. So starting with the numbers, we've got 7 lots of 6. So that'll give us a 42. We've got an a to the 3 times an a, which we can collect together. So that'll give us an a to the 4. We've got a b squared without anything else to bring it with, so we're going to keep it as a b squared. And then we have a c on its own, so let's keep it as a c. So we've brought all our fractions together to give us a single fraction. So now we need to simplify this fraction. So simplifying our fraction, really the way in which we look at this is we compare our numerical parts, then we separate all the algebraic parts to see what can be simplified. In a nutshell, this is equivalent to saying, well, we have 84 over 42 times a to the 4 over a to the 4 times b over b squared, etc. So 84 over 42 is just a positive 2. If we want to keep it in a fraction form, we could put 2 over 1, but the over 1 isn't going to make much of a difference. So I'm just going to leave it as a 2. a to the 4 over a to the 4, they completely cancel out, so that would just give us a 1. Anything times 1 will just be itself, so I'm going to omit that. B over b squared is equivalent to 1 over b, or a b to the minus 1. So that would be equivalent to just having a b within our denominator. So I'm going to have a b within the denominator. And then we have a c squared over c. A c squared divided by c is just c. So I'm going to leave it as a c within the numerator. So final answer 2c over b. Alternatively, we could write that as 2b to the negative 1c. Either perfectly fine. If we wanted to go for a more efficient method, which I won't go through in its entirety, what we can do is compare and cross-cancel terms within the numerators over terms with the denominators. So for example, I could say, well, I have a 3 here and I have a 6 in the denominator. 3 over 6 is equivalent to a half, so I can replace the 3 with a 1. I can replace the 6 with a 2. I can say I've got a 14 here and a 7 here, so 14 over 7 is equivalent to a 2 over 1. And I can do the same things with the letters. So for example, I could go for c squared over c is equivalent to just a single c on the top. I could replace the c with a 1 on the bottom. C over 1 is just the same as c. So we could work our way through that, but we just got to be very careful because there's lots of terms that are going to be cancelling. Okay, on to question 2. Expand and simplify completely. So expanding on 2 sets of brackets. So first bracket, we're going to get 20 lots of t minus 28. Second brackets, we are subtracting 3 lots of the brackets, which is equivalent to negative 3 times everything in the brackets. So negative 3 times 2, negative 6, and negative 3 times negative 40, positive terms, that will give us positive 12t. Collecting everything together, that will give us a 32t minus 28, take away another 6, negative 34. For b, y times 4y, well, the 4 is going to remain as a 4. Y times y gives us a y squared. Y times 6 is 6y with a negative 6y. We have a positive term multiplying through the second set of brackets. So 3y times 2y. Well, 3 times 2 is 6. Y times y is y squared. It's a positive term, so a positive in front. And 3y times 4 is 12y. It's a positive term times a negative term, so that will be a negative 12y. We can collect our y squares and then collect our y's. So 4y squared add 6y squared is 10y squared, and negative 6y, take away another 12y, negative 18y. Do not then look to put that into a factorized form. If I did, we could take out a factor of, what would it be, a 2, a y, and then that will leave us with a 5y minus 9. We were asked to expand and simplify. Factorizing is the opposite of expanding, so we should not go for this additional step at the end because we're undoing the whole expanding process. So our final answer has got to be 10y squared minus 18y. Part C, this is a double bracket expansion, so just be careful, we're not simply squaring the two terms. This is equivalent to 6 minus 7w times another 6 minus 7w. So expanding as per usual, 6 times 6 is 36, 6 times negative 7w, negative 42w. Again, we have a negative 7w times a 6, so we've got another negative 42w. Negative 7w times another negative 7w becomes a positive. 7 times 7, 49, and then a w squared. Collecting the two terms in the middle, 36, subtract 84w plus 49w squared. You could rearrange the order if you want to be written in a usual quadratic way with the w squared leading, but it does not matter. If you were to rearrange, however, just be mindful of the sign. So the 14w squared would still be positive, the 84w would be negative, 36 being positive. Okay, D, another double bracket expansion. 4x times 4x, well, 4 times 4 gives us 16, x times x gives us x squared. 4x times positive 3, positive 12x, and negative 3 times 4x, a negative 12x, negative 3 times positive 3, negative 9. You may have been mindful that this is actually a difference of two squares that we're dealing with here, where we refer to each of these expressions as being conjugates of one another, a phrase that you will be familiar with at an early stage at A level, whereby the two expressions are the same, the sign splitting the two terms is different. So what happens here, the two terms will cancel out in the middle, leaving us with 16x squared, subtract 9. Question 3, factorise the following expressions completely. Now there's always two steps to factorising. You must always check for single brackets first. So what I mean by this is there a common factor that can be taken out a set of single brackets? Beyond this, then we can go on to double brackets. You must always go through in this order if we're looking to factorize completely, and to make your life a little bit easier when potentially solving something like a quadratic or even a cubic um, when dealing with equations. So looking at part A, is there something I can take out of a set of single brackets? The answer is yes. Looking at all three terms, I have a common factor of 3. So we're going to start by taking 3 out of a single set of brackets, leaving us with u squared minus 7u plus 10. Beyond this, I now look at the expression left within the brackets and say, right, can I put this into double brackets? The answer is yes, with our leading terms being u, and then -5 and -2 being the remaining terms. Do not go beyond the step. We are not solving anything here. It's not an equation. There's no equals 0 or anything like that. This is not something that can be solved. It's just an expression that can be put into a different form, which is our factorized state. Question B, is there something I can take outside of a set of single brackets? The answer is yes. I've got a common factor of 2. So I'm going to start with that. So 2 outside the brackets and then v squared minus 25 inside. I've then got a difference of 2 squares. So I'm going to go to my second step of double brackets and split this into v plus 5, v minus 5. And a pair of conjugate expressions, exactly the same expression, but the sign within changing. Okay, question 4. Solve the following equations. First one, expanding our brackets is going to give us a 6 plus 12 minus 8d equals 22. Tidying up the left-hand side, 18 subtract 8d equals 22. As your choice where you want to take the term involving d. It's already on the left, so I'm just going to leave it on the left. This 18 term is positive, so I'm going to subtract it from both sides, giving us a negative 8d equals 4. The negative belongs to the 8d, so it has to remain with the 8d. To remove the negative 8, because negative 8 is multiplying d, I'm going to divide it. So 4 divided by negative 8 is what we'll have on the right hand side. When you have a negative trapped within a fraction such as this, just think about what's going on. I've got a positive term divided by a negative term. Positive divided by negative is equivalent to a negative result, so I'm going to pull the negative in front of the fraction. And then 4 over 8, I could leave as 4 over 8, but we may as well simplify that because we know that that's equivalent to a half. So final answer d equals negative a half. Part B, just looking at it through observation, we can see that it's a quadratic, so I need to make sure my quadratic is equal to 0. Very important, we have it set to equal to 0 before we go through any process involving solving a quadratic. And so I'm going to remove the 21t by subtracting from both sides. So I'm going to have 2t squared subtract 21t plus 10. So I'm dealing with a quadratic. I am going to look to factorize. First step, is there any common factors that I can take out of a single set of brackets? The answer is no. So I'm going to go step 2, double brackets. Will it go into double brackets? If it doesn't, we'd have to use quadratic formula, but this one actually will go into double brackets. So we're going to have 2t and t, and we are going to have negative 10 and negative 1 in the appropriate places. It's always worth checking either in your head or just to one side. Expand these two brackets that we now have to see if indeed it takes us back to the previous expression. If it doesn't, obviously we've made a mistake. It's not worth taking a risk and thinking, oh, that looks right, I'll continue. It's always worth double checking. This is correct, so now we solve. So we want this first expression to equate to 0. So 2t minus 1 has got to equal 0. So solve as a mini equation, mini linear equation. So 2t has got to equal 1, and therefore t is equal to a half. And And second expression, if I want that to equal 0, then t is going to equal 10. So I've got two choices, either t is equal to half or t is equal to 10. Part C, another quadratic. Is there a common factor? There isn't, so I'm going to go straight into double brackets if I can. And after a bit of observation, we'll recognise that we can put it into double brackets. The only option we have for the leading terms is 5s and s. That's the only way in which we're going to generate a 5s squared without going into decimals, which you should always avoid when factorising. And then we'll have to work out what the remaining terms are going to be. So I think we're looking at a -6 and a +2. Just a quick check, that seems correct. So now I want each of my brackets to equate to 0. So I need 5s plus 2 to equate to 0. Take away 2, 5s is equal to -2. Divide through by 5, -2 over 5. Pull the negative to the front. You can do that in an immediate step without going twice over. So that's the same as -2/5. And second bracket, nice and easy. We've just revealed that s is equal to 6. So two options. Either s is equal to -2/5 or s is equal to 6. Question 5. Two straight lines have equations given as above. Solve the equation simultaneously to find the coordinates of the point where the two lines intersect. So we're solving them simultaneously, as stated here. If it weren't stated here, this would be the method we would use anyway to find where two equations overlap each other. We solve them simultaneously to find a point that is common. So I'm just going to write them one above the other. So 2x plus 3y equals 5, 3x minus 2y equals 14. Okay, so first step, I need to make sure my coefficients of x or y are the same. I'm going to go for y, but it's completely up to you. So I'm going to multiply through by 2 for the top equation, multiply through by 3 for the second equation. So that's going to give me 4x plus 6y equals 10 for the top equation, and 9x minus 6y equals 42 for the second equation. Okay, so my coefficients match for y, however, one is positive and one is negative. The only way in which these are going to cancel out is when we add the two together. -6 add 6 will give you 0. If I was subtracting 6, take away -6, two negatives equivalent to a positive, that gives us 12. So just be mindful, it's a GCSE skill, so we should be on top of this, but just be very careful that we don't do something daft here. So we do have to add. So that will cancel the y terms out, leaving us with 13x on the left. On the right hand side, 52. Divide through by 13, that will give us x is equal to 4. We're not done though, we've just found one solution, so now we need to move on to second solution, i.e. for y. So choose any of the four equations, in fact, that we've got involving x and y. So I think I'm going to look at this very first equation up here, because everything's positive. That's quite a nice one to substitute into. So substituting to equation 1, so I'm going to have two lots of 4, add 3y equals 5. So that's 8 add 3y equals 5. Subtract 8 from both sides. 3y equals -3. And that's when we divide by 3 will give us a result of -1. So x equals 4, y equals -1. Just as one tiny additional step, x and y are representing coordinates, so let's just write our final answer in a coordinate form. So 4, -1. And that's our final answer for question 5a. Okay, oops, we do have another question, don't we? 5b, there we go. Okay, question 5b. A line has gradients at 3/2. Straight away, without reading anything else, I know this is going to be a straight line. Because we have a constant gradient, that means that the direction which the line is going will be constant, not changing. So a straight line graph, which means it can be written in the form of y equals mx plus c. So the gradient is 3/2. So we use m to represent our gradient in our general form of a straight line graph equation. So y equals 3/2x. Cuts through the y-axis is 0 minus 5. So that's going to give me the representing value of c. So now I've got my equation of the graph, y equals 3/2x minus 5. Now write the equation of the line, which we've already done, and rearrange it to the form of ax plus by equals c. So notice how it wants the x and the y terms together. So I've got y on the left, so I'm going to take away this x term from the right, so it appears on the left. I'm taking it away because it's a positive term. The negative term on the right is 5, so that's going to remain a negative. And so we're going to have y subtract 3 halves x on the left. If we want to have the x term being our leading term, which we may as well, because that is the form in which it's written in the equation, all I need to do is just make sure that the 3 halves x remains negative, the y term remains positive, and that's how we can just rearrange so it looks like that. Okay, we're not quite done, however. Now a, b, and c are meant to be the numerical parts of this equation, and we're told that they have to be integers. Now we've got the -5 on the right representing c. B is actually represented by 1 because that's the coefficient of y. You don't have to write the 1 in there. That's perfectly fine, leaving it as y. However, the coefficient of x is a fraction. So we need to stop it from being in that form. Easiest way to do that would be to double it, because multiplying by 2 is going to remove that denominator of 2. But be mindful, if you times a single term within an equation by a value, everything is going to be multiplied within the equation by said value. So multiplying through the whole equation by 2, negative 3x plus 2y equals negative 10, and we have a form which is required of the question. If you moved terms in different directions, so for example, if I took this initial y term to the right hand side and took the -5 to the left, so basically my x and y terms are on the right and the value represented c on the left, all we'd end up with would be an expression of 10 equals 3x subtract 2y. They're identical to one another. It just depends on which side you take your terms. So both perfectly fine. Okay, question 6, making P the subject. So what this requires us to do is have P on its own and everything not involving P on the right hand side. You cannot have your subject on the other side of the formula. The idea behind this is if we're using a formula to solve P, in knowing what all the other letters are representing in values, you can't work out P if the steps involving the working out process require you to know what P is. So if my formula was like P is equal to P plus Q, and I know the value of Q, this is like saying, right, to work out P, you need to take P and add Q to it. Well, I can't work that out because I don't know what P is. You cannot have your subject on the other side of the formula. So we need a subject just on one side. So in this first formula, find where your subject is located. Well, it's located in 2 places, both within brackets, so we need to remove it from those brackets. If it's not within brackets, it's not actually necessary most of the time to expand the brackets. But in this case, we're going to have to expand to get them out of the brackets. Not only am I going to expand, I'm actually going to make sure that my terms are written with the letters in alphabetical order. It's not essential, but it does make it much easier when it comes to potential collecting later on. So r times p will give us PR. R times q with the negative is negative qr. Expanding the second brackets, q times p, qb, and q times r plus qr. Okay, expanding the brackets. Next step is to make sure that the terms involving your subject, so P located here, P located here, make sure these 2 terms involving P are on the same side and the terms not involving P are on the opposite side. So what I'm going to do, I'm going to take this PQ term and I'm going to remove it from the right hand side and take it over to the left. So to do that, I'm going to subtract the PQ term because it's a positive term, leaving us with just the QR term on the right hand side, and I'm going to have PR minus QR subtract PQ on the left hand side. So on the left hand side I still have my term not involving my subject, so I'm now going to remove that. It's a negative term, so I'm going to add it. To remove it, do the same on the other side, leaving us with PR minus PQ on the left and QR plus QR on the right. Now, before I start looking at this left-hand side, notice I have two identical terms on the right. Notice that it is in bold and underlined at the top. We want to make sure our formula is simplified where possible. QR plus QR, exactly the same term. I've got two lots of them, so I'm going to write that as two lots of QR. Okay, these two terms on the left, my subject is in two places, but when we're writing a letter as a subject within a formula, it should only appear in one place, and that is on its own on one side equal to everything else. So to get it from two places to one, the trick is to factorize our subject, take it outside a single set of brackets, leaving us with r minus q, and then remove the brackets that are multiplying p by simply dividing the brackets away, doing the same to the other side, leaving us with p is equal to two lots of qr over r minus q. We don't need the brackets anymore. You can keep them in if you want, but we know that we're dividing by all of r minus q, so the brackets won't make any difference if they're there or not. Alternatively, if you took your subject to the right hand side rather than the left that we did, the only difference is you should end up with negative 2qr over q minus r. Potentially you may have the q and the r the other way around, but the q in the second case will be positive, the r be negative. It wouldn't matter if you had it as negative r plus q. They're exactly the same as one another. So either of these final formulae will be perfectly fine to give you the marks. Okay, for B, locate our subjects. Our subject is trapped within a denominator, which is a bit of an annoying place to find it. There's actually a few things that we could do here to solve this formula. Safest thing to do would be to remove our subject from within a denominator form. So in order to do that, I'd have to multiply out of that denominator position. If I'm going to multiply one part of a formula or an equation by something, everything within the formula has got to be multiplied by it. So every single term is going to be multiplied by p now. So I'm going to have PR as my leading term, subtract. It's been removed from the second term, so 1 is going to remain within the fraction. On the right hand side, we're going to have two lots of PR, and then finally subtract PQ. Three terms involved in my subject now, one that isn't. So what I'm going to do, I'm going to add the one to the right hand side. It's negative currently on the left, so it's going to be added to be removed, so that will appear on the right. And I'm going to do two things in one go here. I've moved the one, I'm now going to move the two terms on the right, so they're now on the left. So this 2PR is a positive term, so I'm going to subtract it to remove it to the left. Now on the left, we've already got PR there, so I'm going to subtract 2PR to remove it from the right hand side, and I'm going to add PQ to remove that from the right hand side. So I've done a couple of things there in one go. If you wanted to break it down into several steps, please do, so as not to overly confuse yourself. So what we've got now, we've got three terms involving p. However, before I consider factorizing, I've got to be mindful that I'm looking to simplify where possible, and I've got a couple of terms involving PR. I've got a single PR, subtract two lots of PR, and that will give us negative one lot of PR. I've still got the PQ there, and I've still got the equals 1. Okay, subject is in two places, so I'm going to factorize my subject. So leaving us with a negative r and a positive q equal to 1. Divide through by those set of brackets on both sides, leaving us with p is equal to 1 over negative r plus q. Alternatively, if we wanted to rearrange the two terms on the bottom, we could write that as positive q subtract r. Alternatively, if you took things to the other side, you may have had something like negative 1 on the top and r minus q on the bottom, or negative q plus r on the bottom. Any of these expressions perfectly fine. Okay, final question then. Question 7. The formula for the volume of a cone, and with radius r and height h is a third pi r squared h. Write down and simplify fully the formula for the volume of a cone with a radius of 6r. So this is our formula here. So our volume is equal to what it represents is 1/3 times pi times the radius squared times by the height h. Okay, so we're told that the height is h. The reason why I've written the word radius there rather than just writing r is because this little expression in bold here, 6r, is specifically what the radius has got to be. So I'm going to replace where I have the radius with 6r. Now I'm going to be using brackets here, and hopefully you can recognize why I'm going to be using brackets. The whole of the radius has got to be squared according to the formula, and 6r in bold is representing our radius. It's an expression representing our radius. The r in this expression is a part of a very specific radius. The r within the formula is a variable. It's representing the word radius and could be anything depending on what the cone is. So a little bit confusing, but the r's do represent different ideas. And so with that in mind, I've replaced the concept of the radius, whatever that may be, the variable, with a constant representing our radius of 6r. It's all being squared, hence the brackets. Without the brackets, only the r would be squared because the squared would just be next to r. I just write that to one side. This is not the same as this because this indicates that only r has been squared and then we have multiplication of 6 afterwards, whereas this implies 6r is our term and then the whole thing is getting squared, and that is what we want, not that. Okay, so let's tidy that up a little bit. So 1/3 times pi times 6r times another 6r. A couple of 6's multiplied together gives us 36. A couple of r's times together gives us an r squared times by h. Okay, can we collect anything here? Well, everything has just been multiplied, so we can choose anything that can be potentially brought together to be simplified. We are looking to simplify fully. So the two numbers, 1/3 and 36, can be brought together. There's a couple of ways of looking at this. So 1/3 times 36, we could look at it as a multiplication. In order to multiply a fraction by an integer, all we do is multiply the numerator of the fraction by the integer, which gives us 36/3. The reason for that is because the integer could potentially be written as 36/1. How do we times two fractions? We times the top, we times the bottom, giving us 36/3. Simplifying that, 36/3, 36 divided by 3 is equal to 12. Alternatively, fraction times an integer is equivalent to saying a fraction of an integer. Exactly the same idea. Look at it as 1/3 of 36, which is equivalent to 36 divided by 3, which is also equal to 12. So bringing the numbers together gives us a 12. We've got 12 lots of pi multiplied by r squared multiplied by h, dropping all the multiplication signs, and that is our final answer for the expression of our cone, 12 pi r squared h. Okay, final parts. Part B. So note, because this is a part B, ties in with the previous parts. Often what you'll find in A-level mathematics is that if you have part A, part Bs and everything like that within the same question, there's going to be some sort of link between those questions. So we're told, given the volume of the cone, now very subtle, but it mentions the cone rather than a cone. The cone we worked out in the previous question, the volume of the cone in our previous question was 12 pi r squared h. Let's be mindful of that, is equal to the volume of a hemisphere of radius 2r. So I'm just going to write down here the volume of our cone. So I'm just going to use V subscript C as shorthand. The volume of our cone from part A has got to be equal to the volume of a hemisphere. And we're told the hemisphere has a radius of 2r. Okay, well the volume of our cone, we already know, 12 pi r squared h. The volume of the hemisphere we don't know, so we're going to have to work that out. We're told the constant is representing our radius of the hemisphere, which is 2r. How do I find the volume of a hemisphere? Well, conveniently at the top of the question, it tells us how to find the volume of a sphere. 4/3 times pi times r cubed. The hemisphere is just half of that. Hemisphere being half a sphere. So this is what I'm working with. Now we can actually tidy up this formula a little bit because really you've just got a few things being multiplied together within the brackets. 4/3 times pi times r cubed and then we're timesing by a half. If I wanted to tidy this up, really, I can just bring these two fractions together. A half times 4/3, well, times the top times the bottom. That gives 4/6, and when simplified, that is equal to 2/3. So we could write this as 2/3 pi r cubed as the volume of our hemisphere. So I'm just going to write that over here. However, we have to be mindful that this is a formula where r is representing our radius, our variable for representing our radius. So I'm just going to write 2/3 times pi times radius cubed. Very important, I'm looking at this as being a radius, a generic radius, a variable radius, rather than a specific value r. On this side, r is representing a constant that we were told in part A. We still need to replace our radius, our variable radius, with what we're told the radius of our hemisphere is in part B, which is 2r. So on this right hand side, we're going to have 2/3 times pi times our constant in brackets 2r all cubed. Similar idea to part A, we have it in brackets, it's all being cubed. Let's tidy that up, let's expand those brackets. 2/3 times pi times 2 is being cubed, r is being cubed, so we're going to have 8r cubed. Let's choose to bring the 2/3 and the 8 together, so just over to one side, so 2/3 times 8 times numerator by the integer, that gives us 16/3. So I'm going to have an answer of 16/3 pi r cubed. Okay, so this expression we finally have is equal to the expression for the volume of our cone, which is 12 pi r squared h. So what are we really looking to do here? So we're looking to, underlining this line within the question, find the height of the cone in terms of r. In other words, we need to make h the subject, and everything involving r has got to be on the other side of the formula, I guess. So we want h on its own. So first things first, is there anything nice that we can carry out? Well, we've got a pi on both sides, and there's at least an r squared on both sides. R cubed is the same as r squared times h. So we have at least an r squared on both sides too. So a couple of things in one go that we can do here. Let's divide through by pi, and let's also divide through by r squared. That will actually remove the pi from both sides and divide out an r squared on both sides too, leaving us with a 12h is equal to 16/3. Pi is disappearing. R cubed divided by r squared will leave us with an r. And we're very close to having a final answer now. So now we just have to get rid of the 12 that's with the h. So to get rid of the 12, I'm going to have to divide it through. So I'm just going to move around here. We've got a little bit more space. So h is going to equal, and I'm just going to write what I'm trying to do here, 16/3 r divided by 12. That's what I now need to work out. So dividing by 12 is the same as timesing by a 12th. I won't go into too much detail, but obviously 12 is the same as 12/1. If I want to divide by a fraction, it's equivalent to times it by its reciprocal. So dividing by 12 is the same as times it by 12. Let's bring those two fractions together, so times the top times the bottom. So that is 16/3 times 12, which is 36r. And finally, simplifying 16/36, divide top and bottom by 4, gives us 4/9 r, and that is our final expression for 7 part B.